Hello. This is going to be just a quick review of high level maths paper one that happened today, from someone who actually sat this exact paper. So it was very clearly, excuse me, you know, with the COVID adjustments, we had to skip one question section A, one question section B. First question, definitely very standard algebra here, solving for n and writing an expression in terms of t, that's fine. And then some solving of simultaneous equations, which at first seemed difficult. You might have tried adding the equations together to actually get three, but if you actually, for instance, did twice the second equation and then took that away from the first equation, you'd be left with x and w, so you can form an x and w simultaneous with the third equation. Second equation, again, more standard complex number stuff. Here you have to use the discriminant to get the thing under the square to actually work. And then a very nice De Moivre's theorem question. So nothing really about, say, finding roots. So not as in like, say, z squared equals a complex number or anything. So that was fine. And then we did slightly unique complex numbers question this year. We had to plot this particular complex number and we were told that the complex number O is the origin. We had to find the angle between W and U, so sort of the angle that forms the middle. You could do that in many ways. You might have even found possibly subtracting some amount of the arguments, or you could find the argument of W um, going clockwise compared to pi over 6, and then finding the angle in between it because the flat angle is pi, for instance. That's one way of thinking about it. Question three, standard integral. You can just go straight from the log tables. Hopefully, you've remembered to include the plus c there. And then it's just a functions question with slope of a tangent x equals 2. Set the derivative, put x equals 2 in, and then you can also find the point that it touches if you sub x equals 2 back into the original equation. And then finding the point of inflection, you just set the second derivative to 0. So some very sort of standard stuff here. And then this question came up. Initially when I did it, a lot of people made the same mistake as well, was that they set the derivative of p of x, so they actually drew the lines in representing p of x, and the bits of it that are sort of parallel to L of x. But you have to remember that L of x is a line itself. So it's a line of slope 1/2. So you'd probably have to draw the line at y equals 1/2 and then trying to see where this derivative has bits of 1/2. So it might be, at about 2 point something, or around here perhaps. The, we won't know until the marking scheme goes out about the leniency of that, but it's a very tough paper. Not paper, question. And then this question here, again, standard first principles, should be completely fine. Then some quotient rule. The fraction you got was really, it was a very random fraction, so don't be worried if you assumed it'd be a nice number. It wasn't. And then there was this question, which again a lot of people got stumped by because you had to actually know what a local minimum was, um, which is the point where the derivative is 0. On positive cubic, you hit the local minimum uh, after the max. So if you're going left to right in a cubic, you'd hit the local maximum first, and then the local minimum, and then you'd go back up. But obviously, you have values below 5 in this case because it's a cubic. Okay. This next one, again, very straightforward. Just take the 2 away. Here you set up some equations with A as the first term and R as the ratio. Just remembering that G7 is AR to the power of 6, and then G11 is AR to the power of 10. So we always take one R down. And then this question was actually kind of interesting. The first one was fine, you're just taking a derivative, but the second one might have required a bit of thought. You might have actually tried the tactic of, like a lot of actually Olympiad math problems with this one, is you start with a simpler case and then just see if there's a pattern. If you can see there's a pattern, you can extrapolate what this could actually mean. So I thought it was a very clever question, but might have required quite a bit of thought. And then the last of the long questions, a bit of factor theorem. You can either expand, do long division, which I wouldn't recommend doing long division here, um, or you could sub the fact that x equals 4 is a root and solve for b there, which is actually what I did. Then part B required knowledge of exponentials and logarithms, as well as how to manipulate indices and logs, as well as scientific notation, which is a bit weird. Like I don't actually recall them asking specifically for scientific notation before, so that's a first. Um, this one was also fine. You did actually have to do a bit of manipulation with indices to do this, but overall you should be okay. And then this question here, you should have seen, or at least tried to see, that if you had an e and a log next to each other, and the fact that they were composed on each other, so the composite function, the e and the log would cancel out somehow, and you'd get actually just something in terms of x. Like you don't have any e's or logs or anything. You just get a nice algebraic expression. Then we come to the long questions, where we had a bit of a weird start to this question. It's actually very much a junior cert style question. Like junior cert, higher level people could give this question a bash and um, essentially have no problem with it. And in this question, again, there was a lot of reading, but this question is actually slightly inverted from what normal financial maths questions are. They actually tell you what the monthly repayment was instead of telling you to find it. So everything you had to do was kind of backwards, but once you saw that present value as part of it, then you go to the present value formula in the log tables, and then just be on your merry way with that. Part two, again, just required utilizing either this series or the formula that's in the log tables. Both of them actually give slightly different answers, which is a bit weird, although it might be me typing it into a calculator weirdly, but again, these questions tend to have a bit of leniency, so you should be okay. Part C, again, standard exponential functions question. Differentiating exponentials, all totally normal. Integration, average value. Yeah, so anytime you see average and using integration, yeah, average value theorem, whatever b minus a, integral between a and b. Um, Another thing that I've actually seen as well is that they actually give you a lot of hints. This is also true of the ordinary paper from what I was told. This one again used differentiation to do this, so they actually I feel like they learned their lesson from last year's paper. And then a slightly tricky question at the end to do with actually finding the annual interest. Uh, you just find the values of two values of t. So you can actually start with the initial value of 5,000 and then put t as 1 in here, so 5,000 e to the 0.04, and then find the percentage difference from that, which would be the interest. So overall, actually a very interesting question, kind of throwing bits at you. Question 8, again, another standard functions question. A very nice beginning of summing into a table and drawing a graph. You should have expected the graph to be sort of cubic because of this pair of 3 on the top here. Then we have another question. Again, trig function seems to be making quite a name for itself on paper 1 now, despite the fact that trig itself is very much a paper 2 thing. Maximum minimum value, well, cos is max at 1 and minimum at -1, because cos only goes between 1 and -1. Even this 2 pi t over 365, um, that really it just really sort of stretches the graph and affects the period. So, for instance, it would cycle every 365 days, but that doesn't mean that the height changes. It's still between 1 and -1. So that was okay. Then this question had a bit of weird wording in it because it involved um, putting a function, essentially putting a function inside another. So you'd actually have to put s of t inside of here, and you'd actually end up getting the s of t's to cancel, which is handy enough. And then there was this question. Again, you have to be very careful in reading that it's that involves this s of t, which is a trigonometric one. So you'd actually be looking. We'll give spoilers on this. You'd actually be looking at L because it both represents sine waves and a straight line all into the one. Then they actually give you the derivative of c dash of t, which is handy enough, and then you just have to set that to zero. So, or yeah, set it to zero and then solve for t, which um, it gives you the first local maximum of c, which is actually okay. Especially with a graph like this, if you take the first one, sine actually starts off with being a maximum. You go from a point of inflection at the normally with a sine graph, you hit a point of inflection at the origin, and then the first one you get to, because it's a sine curve, the first one you get to is your local maximum for that period. So it's quite an average question actually. There wasn't anything hopefully too difficult about it. Question nine, again threw a bit of shapes into it, but it actually really didn't because of it actually gave you what the formula was. You didn't have to like derive it or anything. Again, just something to formulate. Now this bit here, it gave it as units squared, which I think is actually kind of funny. We were told to actually change it to units cubed, and thankfully there are actually no units here at all, so you didn't have to worry about much units for the cap. Um, yeah, again, just testing the formulas, and then you use the quadratic formula here again because you end up with a y squared. Now, units didn't matter in the previous question, but I do here. If you didn't know that 1 liter is 1,000 cubic centimeters, then that might have thrown you a bit because I didn't actually tell you what 1 liter was in centimeters cubed. So it says final value of x in the hemisphere is 3 liters, so you'd actually put this as 3,000 because we're dealing with cubic centimeters. And then we have a nice related rates of change question with all the units actually matching. So if cubic centimeters is centimeters, so it's grand. Do we do it? We're looking for a dx dt, so you have a dx and a dt, the one that's missing is dv. So you'd find dv by dx and then just do 1 over that to find dx by dv. And then a weird algebra question that required you to put on a common denominator and then notice that on the bottom you have a pi squared r squared because you end up squaring this pi r, uh, which actually removes the square root on the bottom, which may have tripped some people, but it should have been okay to those who paid attention. And then lastly, we have this question about some spinach plants, the height of them. We're using W for the function, I guess. Well, for spinach is water, I guess hadnic. We're exiting where they start growing. So again, just subbing into a formula that's fine, finding the derivative. Then you actually do a quadratic inequality here, where the quadratic is negative, so it's an N shape. It's a sad quadratic, as I say to the people I teach. Then we have this. It looked really scary the first time we do it, but actually, it's just the area of the top minus the area of the bottom, and then you times it by two because it's under what does it say? Yeah, it's under actual symmetry, so they're literally the same thing. They're just flipped. And then this question required a bit of thought about how to actually transform functions. If you want to know, the way I thought of it was that both of these have a turning point here. One of them's at one, one's a negative one, and they will have roots that are spaced apart if it's actual symmetry. So this will probably have roots of 0 and 2 because it's s of x, so it'll have roots 0 and 2. That means the other one must have roots of 0 and 2 as well. So you just come up with a quadratic that has a turning point at x equals negative 1 and the two roots being 0 and negative 2. Then the last part, I don't think there's going to be many marks going for this because it's tick the box one. But this question it has been a bit controversial from the people I've talked to. Now, I originally thought option one because I'm stupid. There's sort of equal ways between option two and then it depends on P and R. Because option two, when you actually do it out, it appears that option two is actually the one you go for. No, option one, sorry. It's kind of weird. Yeah. So option one was I chose option two. I chose the wrong one. I don't know why I was thinking option one. So what I'm saying, sorry, is that option one might have been the correct answer. Option two definitely isn't. But there has been people going saying that it depends on P and or, which I haven't actually investigated, but pretty much any of option one or it depends will probably have some merit. And that's the end of the paper. To be honest, what I thought of it as someone who actually sat the exam, I thought it was reasonably okay. It was one of the easier paper ones they've ever released. So let's hope that paper two is just as nice. But it tends to be that whenever there's a nice paper one, there's a bad paper two, or really vice versa. So once you actually practice a lot on theorems, because the theorems 11, 12, 13 haven't come up in a while, and yeah, just really be prepared for it.